so this is the unpleasant part of matrices by hand. It's just tedious. I'm pretty sure I didn't make any of these problems have fraction answers, nor do any of the problems have no solutions or infinitely many solutions. Just like when I was working the matrices that had just the x's and y's, I'm going to create an initial matrix. I'm going to make a column for the x's, a column for the y's, a column for the z's, a bar for the equal sign, this is going to be my initial matrix for problem 14. I'm going to get a second matrix, a third matrix, and a final matrix. The final matrix I'll be able to read off my solution. The final matrix, I'm going to know what it is ahead of time because I'm going to do this on my calculator. This particular matrix, it has three equations. Each equation is a row. So there's 3 rows. There's an x column, a y column, a z column, and an equals column. There's 4 columns. This is a 3 by 4 matrix. The only difference between the calculator activity for this than the last ones is the dimensions. So I'm going to do exactly the same thing on my calculator. Specifically, I'm going to go a second matrix, get the names, the edit, and the A highlighted. It's no longer a 2 by 3 matrix. It's going to be a 3 by 4 matrix. So the only thing on my calculator that's going to be different is the dimensions of the there. So I'll go edit, type in 3 and enter, 4 and enter. Now I'll enter the numbers 3, enter, -2, enter 1, enter 15, -1, 1. I think I messed up there. 2, -10, 1, -1, -4, 14. It's crucial that you double check yourself. So 3, -3, -1. I'm double and triple checking to make sure I have everything entered as well as it can be entered. If you have one sign wrong, one number wrong, the whole thing is wrong. So when I made my initial matrix, there were a lot of ones that are negative ones I had to put in because a bunch of the letters were missing numbers. And if there's not a number in front of the letter, there's an implied 1. There's a negative without a number, there's an implied -1. So I entered my matrix. Now I'm going to go second quit, second matrix, get the math and the RREF highlighted. It's no different on my calculator. My calculator doesn't care how big the matrix is. My final matrix is going to be 1, 0, 0, 5. 0, 1, 0, -1, 0, 0, 1, -2. So on my calculator, I was able to do the same keystrokes for a bigger matrix. If I wanted to, the top row says 1x plus 0y plus 0z equal to 5. The middle row says 0x plus 1y plus 0z equals to -1. And the bottom row says 0x plus 0y plus 1z equal to -2. Simplifying those, because the zeros just kind of work themselves away, the top row says x equal to 5. The middle row, the x and the z goes away, leaves me with y equal to -1. The bottom row says z equal to -2. So the answer to this, just like the answers for the x's and y's, just come right down the right-hand column. It's x equal to 5, y equal to -1, z equal to -2. So I know the beginning, I know the end. I need to get a second and a third matrix, and that's the tedious part. It takes me 3 steps to get from the initial matrix to the final matrix, and each one of those steps has double elimination methods. So I'm going to leave myself lots of room and start this on a new piece of paper. So I know the beginning, I know the end, I know the answer. So my initial matrix is 3, -2, 1, 15, -1, 1, 2, -10, 1, -1, -4, 14, my first step is going to be to pair the top row with the other two and eliminate the x's. And I'm actually going to show that in a little more detail. So the top row is 3, negative 2, 1, 15. I'm going to pair it with the middle. And I'm going to pair it with the bottom. Every time I'm going to do this same first step. And specifically, the x's, I need to make those two zeros. On this step, this -1 and that 1 are going to turn zeros. I'm going to get a new second row and a new third row on my second matrix. So my goal is to make that -1 into a 0, that 1 into a 0. I'm just using the elimination method. To do this, I'm going to multiply that by 3. And when I do that, I'm going to leave the 3, -2. I'm going to leave the 3, -2, 1, and 15. Multiply by 3. 3 times -1 is -3. 3 times 1 is 3. 3 times 2 is 6. 3 times -10 is -30. Add, I get 0, 1, 7, and -15. This is going to be now row 2. Because it came from row 2, it's where I want the 0 to be. So in my second matrix, that's going to be row 2. Row 1's not going to change. I'm going to change row 3 here in a second. I'm going to take this and multiply it by -3 to make my x's cancel. I'm going to leave the top at 3, -2, 1, and 15. Multiplying this by -3, I'm going to get -3, +3, +12, -42. Add and get 0, 1, 13, and -27. I'm going to do a couple things on my calculator to make sure I haven't messed up. Specifically, -3 times 14 was okay. 15 minus 42 was okay. So this right here in my second matrix is going to be row 3. So I'm going to go from my initial matrix, and now I'm going to write a second matrix. My second matrix, and I'm also going to have a third matrix before my final matrix. My second matrix, the top row is going to stay at 3, -2, 1, and 15. I'm going to get a new row 2 at 0, 1, 7, and -15. And a new row 3 at 0, 1, 13, and -27. That's the end of my first stage. I went from my initial matrix, paired the top row with the other two and eliminated the x's, got to my second matrix. Done with the initial matrix, won't ever use it again. Now, next step is going to be to pair the middle with the other two and drop the y's. So the middle row at 0, 1, 7, and -15, I'm going to pair it with the top equation, 3, -2, 1, and 15. And I'm going to pair the middle, 0, 1, 7, and -15 with the bottom equation, 0, 1, 13, and -27. And I'm going to get the zeros that my answer needs in the y column that's above and below in the first and third row. So I'm going to get this I'm going to turn into a 0, and that I'm going to turn into a 0. I'm going to circle these things that I need to be turned into a 0. On this stage, I'm going to get a new row 1, and I'm going to get a new row 3. So first step, pair the top, drop the x's. Middle, second step, pair the middle, drop the y's. Last step is going to be pair the bottom, drop the z's. So to make that into a 0, I'm going to multiply this top by 2. When I do that, I'm going to get 0 times 2 is 0, 1 times 2 is 2, 7 times 2 is 14, -15 times 2 is -30. I'm going to leave the bottom at 3, negative 2, 1, and 15. Add these together. 3 plus 0 is 3. 2 and negative 2 is 0. 14 and 1 is 15. Negative 30 and positive 15 is negative 15. All those numbers are divisible by 3. I'm going to divide them by 3 before I make a new top row. So 3 divided by 3 is 1, 0 divided by 3 is 0, 15 divided by 3 is 5, negative 15 divided by 3 is negative 5. In my third matrix, that's going to be the top row. So instead of writing 3, negative 2, 1, 15, I'm going to write 1, 0, 5, negative 5. I'm going to get one more 0. Kind of doesn't matter how I attack this. I'm going to multiply this by negative 1 and add them together. And I do this. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1. Negative 1 times 7 is negative 7. Negative 1 times 15 is positive 15. I'm going to stack that on top of 0, 1, 13, and negative 27. 0 plus 0 is 0. Negative 1 and 1 is 0. Negative 7 plus 13 is 6. 15 and negative 27 is negative 12. Again, this is divisible by 6, so I should do that division just to make my work in the future easier. When I divide those by 6, I get 0 divided by 6 is 0, 6 divided by 6 is 1, negative 12 divided by 6 is negative 2. That's going to be my bottom row. So I went from my first matrix that I pulled off the coefficients, then I paired the top with the other two, eliminated the x's, got my second matrix. Now I'm ready to get my third matrix. My third matrix is going to have this for the top row. The middle row is not going to change. The bottom row is going to be that. So for my third matrix, and the third matrix will lead me to my final matrix. The top row is supposed to be 1, 0, 5, and negative 5. The middle row still, I haven't changed that middle row. I didn't put a 0 in there, so it's 0, 1, 7, negative 15. And the bottom row is 0, 0, 1, and negative 2. Never going to use that second matrix again. I'm completely done with that second matrix. Now I'm ready to get to my answer. The last step is to pair the bottom with the other two and drop the z's. Very specifically, I'm going to get the zeros where the 5 and the 7 are. I'm going to make that a 0 and that a 0. And that's going to take me from the third matrix to my final matrix that I know where I'm shooting for. At the end of this stage, I'd like to be right there to have that matrix that my calculator told me I needed to get. So to do that, I take the bottom equation, which is 0, 0, 1, and negative 2, and put it on top of the top equation, 1, 0, 5, and negative 5. Put it on top of the bottom equation, or the middle equation, 0, 1, 7, and negative 15. I need to make this 5 and those 7s into zeros. Easy enough to do both of those. To make this 5 into a 0, I multiply the top by negative 5. When I do that, 0 times negative 5 is 0. 0 times negative 5 is 0. 1 times negative 5 is negative 5. Negative 2 times negative 5 is positive 10. Leave this 1, 0, 5, and negative 5. Add these together, I get 1, 0, 0, and 5. This is going to be my top row. Because I used my top row, it's going to be my top row. Next pair, I'm going to multiply this by negative 7 to make that 7 cancel. I go negative 7 times 0 is 0, negative 7 times 0 is 0, negative 7 times 1 is negative 7, negative 7 times negative 2 is positive 14. I'm going to leave the 0, 1, 7, and negative 15 alone. Add these together. 0 plus 0 is 0. 0 plus 1 is 1. The 7's cancel. 14 and negative 15 is negative 1. That's going to be my middle row. Now I'm ready to go from my third matrix to the final matrix. The top row is going to be 1, 0, 0, and 5. The middle row is going to be 0, 1, 0, and negative 1. The bottom row is going to be 0, 0, 1, and negative 2. If I look at that and what my calculator gave me, they're identical. So that's beautiful. This answer is still the same. This final matrix is still right. The things that when I'm grading that I'm going to be really looking for is the correct second and third matrix, because the initial matrix just comes from looking at from the problem itself. The final matrix and the answer really comes from my calculator. It's the second and the third matrix that require the being clever. So to summarize, the strategy that I'm going to use to solve this is, first one I'm going to do first. I'm going to do the top with the other two and eliminate the x's. That will give me a new row 1, new row 2, and a new row 3. For my second step, I'm going to pair the middle with the other two and eliminate the y's. That's going to give me a new top row and a new bottom. And I probably could have said a new middle and a new bottom. And then the third step, I'm going to put the bottom with the others. I'm going to eliminate the z. That's going to give me a new top and a new middle. Not that that's readable, but that's what I'm doing. First step, top with the other two, eliminate the x's, gives me a new middle and a new bottom. Second step, take the middle with the other two, eliminate the y's, that gives me a new top and a new bottom. The third, the bottom with the other two, eliminate the z's, gives me a new top and a new middle. So first, top with the x's, middle with the y's, bottoms with the z's, and it's every single time. It's just systematic. I do the same thing regardless of how ugly the math gets. That's what I'm going to do for every one of these that have x, y's, and z's. But before I do anything, I steal the answer from my calculator because I like to know the answer ahead of time. So my initial matrix for number 16 is going to be 4, 4, 4, 12, 4, a lot of dividing I could actually do here, negative 2, negative 8, negative 12, 5, 3, 8, 21. That's my initial. My final matrix that I'm shooting for, and my answer I'll know before I do any algebra. I suspect that the final matrix is going to look like that, other than it's going to have numbers to the right of the equal sign. So when I do this, I do second matrix, edit. It's a 3 by 4 matrix. Type in the numbers the way I see them. If you would have did some division ahead of time, you'd be working with smaller numbers, which isn't necessarily a bad thing. But I'll pretend I didn't see that the top row could be divided by 4, the middle row by 2. So make sure I enter that right. 4, 4, 4. So you've got to have it dead on perfect. After I have it entered, second quit, second matrix, math, up to RREF is quicker than down. Second matrix, enter, enter. The answer to this is going to be x equal to 1, y equal to 0, z equal to 2, and I'm going to write that as 1, 0, 2. If that's all you did, you certainly wouldn't get much credit, if any credit, on the test. So really, what you write for your second matrix and what you write for your third matrix is where I'm going to give you your credit. So to get from the initial matrix to the final matrix, step 1 is pair the top with the other two and eliminate the x's. So my first step, I'm going to get that 0 and that 0. by pairing the top with the other two and eliminating the x's. If I would have divided these rows and made them smaller, it would have made some sense to do that, but I'll pretend I didn't see that just because that doesn't happen that often at the initial. So I'm going to do the top with the other two and eliminate the x's. So the top was 4, 4, 4, and 12. So I'm going to stack that top, 4, 4, 4, and 12, on top of the middle, 4, -2, -8, and -12. Eventually that will give me a new middle. And over the bottom, 5, 3, 8, and 21. So all I did is just took that top row, paired it with the middle, paired it with the bottom, because I said to pair the top with the other two and eliminate the x's. So now I'm going to eliminate this, get a 0 there, and get a 0 there. This is the easier 0 to get. I'm going to multiply this row by -1. I'm going to leave this at 4, 4, 4, and 12. Multiply here, get -4, +2, +8, +12. Add these together, I get 0, 6, 12, and 24. I'm not going to keep not dividing. I'm going to divide these by 6. Before I make my second matrix, when I get some of this division done that I can do, this is going to give me 0, 1, 2, and 4. This is going to be the middle row. Because I use the middle row, it's going to turn into the middle row. For this one, I have to do double multiplication. I'm going to multiply this by 5 and that by -4. Top by 5 is going to give me 20, 20, 20, and 60. Bottom by -4 is -20, -12, -32, -84. Adding, I get 0, 8, -12, -24. Dividing all of these by 4 before I throw them into my matrix. 0 divided by 4 is 0, 8 divided by 4 is 2, -12 divided by 4 is -3, -24 divided by 4 is -6. That's going to be my bottom row. So my top row is going to stay this 4, 4, 4, 12. I get a new middle row and a new bottom row. That's going to get me to my second matrix. So I'm ready to write my second matrix. Top row stays at 4, 4, 4, 12. Let me divide everything in that. I don't want to work with that 4, 4, 4, 12. It bugs me that I didn't divide this. I'm going to divide everything in that row by 4 because those are all divisible by 4. It's going to make the numbers a lot easier to work with. So normally that doesn't happen, but anytime a row is divisible by a number, you can do that division. It just makes the numbers smaller. So rather than writing the 4, 4, 4, 12 again, working with those large numbers, I divided each of these 4s, and that 12 by 4 made it 1, 1, 1, 3. Now I'm going to get the middle row from my algebra, which was 0, 1, 2, and 4. And the bottom row from my algebra, which is 0, 2, -3, and -6. Not going to use the initial matrix again. I'm completely done with the initial matrix. Done with that first step. The next step now is to do the middle with the other two and drop the y's. And specifically, in my answer, I'm going to be getting those zeros, the zeros in the y column. So I'm going to be making this into a 0 and that into a 0. So I'm going to do that work. I'm going to take the middle, 0, 1, 2, and 4, pair it with the top, 1, 1, 1, and 3. Take the middle, 0, 1, 2, and 4, pair it with the bottom, 0, 2, -3, and -6, and work on making this into a 0 and that into a 0. Easy enough to do. For this, I'm going to multiply the top by -1 to make that happen. I'm going to get a 0, a -1, a -2, and a -4 when I multiply that row by -1. leave the 1, 1, 1, and 3. When I do that, I'm going to get 1, 0, negative 1, and negative 1. And that's going to be my top row in my third matrix. For this set over here, I'm going to multiply this by negative 2. Go negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 4 is negative 8. Stack that on top of 0, 2, negative 3, negative 6. Add these together. I get 0, 0, negative 7, negative 14. Those are all divisible by negative 7, so I'm going to do that division. I'll go 0 divided by negative 7, 0 divided by negative 7, negative 7 divided by negative 7, negative 14 divided by negative 7, and get 0, 0, 1, 2 for my bottom row. So my third matrix, I have that 0, 1, 2, 4 middle row, and a new top row and a new bottom row. So now I'm ready to write my third matrix. The top row is 1, 0, negative 1, negative 1. Middle row didn't change. It stays 0, 1, 2, 4. Has a new bottom row at 0, 0, 1, 2. Done with the second step, into my last step. Pair the bottom and drop the z's. So I do top, middle, bottom, x, y, z. Specifically, I'm going to get those two zeros, which is that to be a 0 and that to be a 0. So to get that there, to get to my answer that I already know, and to the final matrix that I already know, I just need to do a little bit of algebra. So again, when I'm grading, that second and third matrices that I have are the big deal. The rest of this isn't such a big deal. So I'm taking the bottom, 0, 0, 1, and 2, pairing it with the top, 1, 0, negative 1, and negative 1, and the middle, 0, 1, 2, and 4, and getting some zeros, making this negative 1 into a 0, and that 2 into a 0. I like to circle what I'm turning into a 0. It just makes it easier for me to keep these things straight in my mind because it gets to be kind of overwhelming. When I do this one, I can just add these together and get 1, 0, 0, 1. That's going to be a top row. This eventually is going to give me my middle row, but I have to multiply first. I'm going to multiply this by negative 2. When I do that, I get 0, 0, negative 2, negative 4. Leaving the 0, 1, 2, and 4. Adding, I get 0, 1, 0, and 0. That's going to be my middle row. And that's going to take me to my final matrix, which I already knew. I already have written down, but the top row is supposed to be 1, 0, 0, and 1. The middle row is supposed to be 0, 1, 0, and 0. The bottom row is supposed to be 0, 0, 1, and 2. If I compare that to what my calculator gave me, it's spot on identical. So the answer that I came up with at the beginning was completely right. I've confirmed it by hand. Again, if this was all you showed was the initial matrix, the final matrix, and the answer, I don't know if I'd give you any partial credit, but it wouldn't be much. When I go to grade, real specifically, I'm going to look for the second matrix and the third matrix to make sure they're look like mine or something similar to mine. They can be slightly different if you choose to do your negatives differently or choose not to divide when I chose to divide, but they won't be radically different. Two more of these to get through. They're not going to be any different, but they're not going to be any shorter either. So 18, I'm going to know the answer, know my initial matrix, my final matrix, and my answer before I do any algebra. I don't like that 19 is such a large number. It's going to make it easy to make a mistake. That's my initial matrix. I know my final matrix is going to look something like this. The answers are going to be in that right-hand column alphabetically too. So I'm going to enter that in my calculator, do the RREF, and get my solution. So hopefully your calculator is getting easy for you. We're only in this section ever going to do 2x3s or 3x4 matrices. In the next two sections we'll get different sized matrices, but it's nothing to worry about now. The next two sections are a lot easier than the first two sections. So again, you have to make sure you get all the numbers in properly. If you don't get the numbers in properly, it's a fraction answer. Ugh. Unfortunately, when you get a fraction answer, you're going to get an extra matrix. So I'm going to get actually a fourth matrix. Surprised that I put a fraction in here. I'm going to double check to make sure. 1, 1, 1, 6, 2, 3, 1, 11, 5, 4, 2, 19. Make sure I've actually entered that properly. 1, 2, 5, 1, 3, 4, 2, 1, 2. Yeah, I'll just have to live with it. When you get fractions, you get an extra step. So I'm going to have an initial matrix, a second matrix, a third matrix, a fourth matrix, and then my final matrix. The fractions add one layer of difficulty, but they keep the numbers bigger, but I don't do any algebra with fractions. The fractions, I'm going to hold off for any fractions until my last step. So first step, I'm going to get these zeros. I'm going to pair the top equation with the other two. Drop out the x's. So my first step, I'm going to take that top equation, 1, 1, 1, 2, 6. 1, 1, go crazy with the ones. 1, 1, 2, 6. Pair it with the middle, 2, 3, 1, and 11. And the top 1, 1, 2, 6. Pair it with the bottom, 5, 4, 2, 19. And make this 2 into a 0, make that 5 into a 0. Once I do that, I'll have a new matrix that I'll call my second matrix. The top row is going to stay the 1, 1, 2, 6. The middle and the bottom row are going to be new. So as I go through this, to get this 2 to be a 0, I'm going to multiply this by -2. I get -2, -2, -4, -12. Put that on top of my 2, 3, 1, 11. That's going to give me 0, 1, -3, -1. That's going to be my middle row because that 2, 3, 1, 11 was my middle row. Multiply this by -5. Go -5, -5, -10, -30. On top of 5, 4, 2, 19, I get 0, -1, -8, -11. The best I can do is make those negatives positive, but sometimes negatives help me out. I'm going to leave those negatives around for a bit. So now I'm ready to make a new bottom row, a new middle row. My top row is not going to change. So when I go to make my second matrix, the top row is going to stay that 1, 1, 2, and 6. So this is now my official second matrix. Top row stays 1, 1, 2, and 6. The middle row changes to 0, 1, -3, and -1. The bottom row becomes 0, -1, -8, and -11. Done with the initial matrix, done with this step. The next step is to pair the middle with the other two. Drop the y's. Very specifically, I'm going to make this into a 0 and that into a 0. So I'm going to take the middle equation, 0, 1, -3, and -1, which is the middle equation. Pair it with the top equation, 0, 1, 2, and 6. Pair it with the bottom equation, 0, -1, -8, and -11. Shoot for my zeros. That needs to be a 0. That needs to be a 0. To make this a 0, I'm going to multiply this by -1 and then add them together. I'm going to get -1 times 0, -1 times 1, -1 times -3, -1 times -1. over the 0, 1, 2, and 6. This is going to become a top row because I'm using the top row. It's going to be 0, 0. Whoa, 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 whoa. It's going to become, really, hold on. The middle, I made a mistake. Oh, forgot this 1 right here. This right here, I wrote 0, I should have wrote 1, 1, 2, 6, and so this right here should be a 1. I could tell something was going wrong, and what went wrong is instead of writing 1, 1, 2, 6, I wrote 0, 1, 2, 6. So this right here should be 0 plus 1 is 1, negative 1 and 1 is 0, 3 plus 2 is 5, 1 plus 6 is 7. That's going to be my top row. These two I could just add together and make that negative 1 cancel out. So I always like to use multicolors, circle the thing that I'm trying to make zeros. It keeps me focused. And I use kind of 1 sheet per step, or at least maybe do 2 steps at most on a sheet. Save yourself a lot of room and it'll make it easier to track your work. So from my second matrix, the middle row is going to stay. The top row is going to, on my third matrix, and the bottom row are going to change. I could change those signs, but I'm not going to right yet. I like negatives sometimes are helpful. So now I'm going to go for my third matrix. My top row is going to be 1, 0, 5, and 7. My middle row is going to stay this 0, 1, negative 3, negative 1. And my bottom row is going to be 0, 0, negative 11, and negative 12. So I'm done with the second matrix. Don't need to look at it again. I'm going to use the bottom with the other 2 and drop the z's. Very specifically, I'm going to make these 2 into zeros. So I'm going to do that stacking. I'm going to stack the bottom 0, 0, negative 11, and negative 12 on top of the top and on top of the middle. So I'm going to put it on top of the 1, 0, 5, and 7, and on top of the 0, 1, negative 3, and negative 1. Remind myself what I'm trying to make into a 0. This is a bad one. I have to do double multiplication. I'm going to multiply this by 5 and that by 11, and that's going to make the things go away. So for the top, 5 times 0 is 0, 5 times 0 is 0, 5 times negative 11 is negative 55, 5 times negative 12 is negative 60. Bottom, 11 times 1 is 11, 11 times 0 is 0, 11 times 5 is 55, 11 times 7 is 77. When I combine these together, I get 11, 0, 0, 17. That's going to be my top row in my fourth matrix, and then from my fourth I'll go to my final. This is a mess. Here I'm going to multiply these by negative 3, this by positive 11 to get the 33s with opposite signs. This by negative 3, I get 0, 0, 33, because negative 3 times negative 11 is positive 33. Negative 3 times negative 12 is positive 36. And then 0, 11 times 1 is 11. 11 times negative 3 is negative 33. 11 times negative 1 is negative 11. Add these together, I get 0, 11, 0, and 25. That's going to be my middle. So when I have fraction answers, I pick that up an extra bit of work. And my fourth matrix, the new top row is going to be 11, 0, 0, 17. The new middle is going to be 0, 11, 0, 25. The bottom is 0, 0, negative 11, negative 12. Won't use that third matrix anymore. And it's an easy step to go from my fourth to my final. For the top row, I'm going to divide everything in the top row by 11. When I do that, 11 divided by 11 is 1, 0 divided by 11 is 0, 17 divided by 11 is not reducible. That's going to be the top row in my final. Do the same thing for the middle. The middle was 0, 11, 0, 25. I'm going to divide everything in the middle row by 11. Doing that, 0 divided by 11 is 0, 11 divided by 11 is 1, 0 divided by 11 is 0, 25 divided by 11 doesn't reduce. And then for the bottom, I have 0, 0, negative 11, negative 12. I'm going to divide everything in there by negative 11. Zero divided by negative 11 is 0. 0 divided by negative 11 is 0. Negative 11 divided by negative 11 is 1. Negative 12 divided by negative 11 is 12 over 11. So my final matrix is going to have 1, 0, 0, 17 over 11 for the top, 0, 1, 0, 25 over 11 for the middle, 0, 0, 0, 1, 12 over 11 for the bottom, which is exactly what my calculator gave me. The answer is x equals 17 over 11, y equal 25 over 11, z equal to 12 over 11. One last problem to do. Hopefully it doesn't bless me with fraction answers again. Same thing. There's nothing new for any of these problems. They're all very, very structured. So my initial matrix for 20 is 1, negative 1, 1, and 2, 2, 1, 1, and 5, 7, 4, negative 1, and 9. That's my initial matrix. Enter that on my calculator. Second matrix, edit, 3 enter, 4 enter, 1 enter, negative 1, 1, 2, 2, 1, 1, 5, 7, 4, negative 1, 9. Make sure I've entered it right because I'm worried I didn't. 1, 2, 3, 1. Good enough. Then second matrix, math, RREF, second matrix, enter, good. The final matrix is going to be 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 2. The answer is going to be x equal to 1, y equal to 1, z equal to 2. I'm almost out of paper, so I'm going to try to do the first step on here. First step, I do the top with the others and get some zeros. I'm going to get that and that to be a 0. My top is 1, negative 1, 1, and 2. I'm going to pair that with both the middle and the bottom. So I'm going to pair that with the 2, 1, 1, 5, and the 7, 4, negative 1, and 9. I'm going to make that 2 into a 0, and this, which is supposed to be a 7, I believe, doesn't really look like a 7, and that 7 into a 0. To do that, I'm going to multiply this by negative 2. I'm going to get negative 2, positive 2, negative 2, negative 4, stacked on 2, 1, 1, 5. When I do that, I get 0, 3, negative 1, 1. That's going to be my middle row. Next combination, I'm going to multiply here by negative 7. I'm going to get negative 7, positive 7, negative 7, negative 14, and I have a 7, 4, negative 1, and 9. Add these together, I get 0, 11, negative 8, and negative 5. That's going to be my bottom. So I'm ready for my second matrix. My second matrix, the top row is going to stay at 1, negative 1, 1, and 2. The middle row is going to become 0, 3, negative 1, and 1. The bottom is going to be 0, 11, negative 8, and negative 5. Now I'm going to pair the middle with the other two. So I'm going to do the 0, 3, negative 1, and 1. Pair it with the top, 1, negative 1, 1, and 2. In the middle, 0, 3, negative 1, and 1. And pair it with the bottom, 0, 11, negative 8, and negative 5, and get some zeros. Again, I always try to circle the zero I'm attacking so I know what I'm shooting for. This one's the easier one to get. I'm just going to multiply this by 3. I'm going to go 0, 3, negative 1, 1, 3, negative 3, 3, 6. Add these together, I get 3, 0, 2, 7. That's going to be the top row when I get to my next sheet of paper. This is the messier one. I'm going to multiply this by 11, this by minus 3. This by 11, I get 0, 33, negative 11, 11. This by negative 3, I get 0, negative 33, 24, 15. Add, I get 0, 0, 13, and 26. I don't want to enter that because I can divide everything here by 13. Do 0 over 13, 0 over 13, 13 over 13, 26 over 13. That's going to make that 0, 0, 1, and 2. And that's going to be the bottom. So I'm ready to go from my second matrix to my third matrix. My top row is going to change to 3, 0, 2, 7. My middle row is going to stay at 0, 3, negative 1, 1. My bottom row is going to be 0, 0, 1, 2. So I'm going to pull out my last sheet of paper, and my top row needs to be 3, 0, 2, 7. This is my third matrix. I didn't do any circling on my middle row, so it's going to stay at 0, 3, negative 1, 1. And my bottom row wound up being a 0, 0, 1, 2. So I'm done with that step, getting ready to go to my last step, pairing the bottom with the other two, getting a few more zeros. So I'm going to pair this bottom one, which is 0, 0, 1, and 2. I'm going to pair it with the top, 3, 0, 2, and 7, and pair it with the middle, 3, 0, 3, negative 1, and 1. And I need to make this 2 into a 0, this negative 1 into a 0. Easier to do this. I'm going to multiply this by negative 2. I go 0, 0, negative 2, negative 4, stacked on top of 3, 0, 2, 7. When I add these, I get 3, 0, 0, 3. Before I enter these into my matrix, I'm going to divide by 3. When I divide by 3, I'm going to get 1, 0, 0, 1. This is going to be my top and my final matrix. These two, that 0 will happen by just adding them together. So I'm going to add them and get 0, 3, 0, 3. Divide by 3. And get 0, 1, 0, 1. That's the middle row. So the next matrix I'm going to get has the top row of 1, 0, 0, and 1. Has the middle row of 0, 1, 0, and 1. Has the bottom row of 0, 0, 1, and 2, which makes the answer x equal 1, y equal 1, z equal to 2. If I looked at my initial work on my calculator said that was the matrix I was shooting for. That's my answer because those tie perfectly with each other. Then I'm reasonably certain I didn't make an error. If I made an error, it's probably writing the problem down wrong, doing the wrong problem by hand and the wrong problem on my calculator, because the chances of getting your algebra to match up with your calculator and having made the same mistake, there's a slim chance of that. So these are tedious, but it's just doing the elimination method 6 times, and it's very structured. Top with the other 2, drop out the x's. Middle with the other 2, drop out the y's. Bottom with the other 2, drop out the z's. You should be able to know what the answer is before you do any algebra on your calculator, which is the nice thing about these. And the good thing about these matrices that we just did, any of the problems that we did in the last section that we didn't use substitution for, those also you could check via your calculator. So all those problems in 6-1 that had the 3 equations and 3 unknowns that were so tedious to do, I could know what the answer is before I start those by doing the RREF on my calculator. Even though I wasn't solving those with matrices, all of the problems in 6-1 where the x's and the y's or the x, the y's, and the z's were all lined up could also be done and checked via matrices. All right, that's got to be